Assalamualaikum and hello everyone. Welcome back to my channel. In this video, we will going to discuss about the computer-aided engineering drawing. We will discuss about the topic projection of planes. Now let's move on to the topic. In this presentation, we will understand the overview of projection of planes in CAD. Introduction to plane geometry. What is a plane? A plane is a flat, two-dimensional surface extending infinitely in all directions. What are geometric shapes? Guys, you all know geometric shapes are like squares, rectangles, triangles, and hexagons, pentagons are different within a plane. Principles of orthographic projections. Multi-view projection. Orthographic projection creates multiple views of an object, each representing a different face. What are projection planes? Projection planes are imaginary surface onto which these objects' features are projected. View direction. In this CAD, the view directions is more important. Projection lines are drawn perpendicular to the projection plane, forming a true representation of the object. Projection of geometric planes. Square. Square is a four-sided plane with all sides equal and all angles right angles. Rectangle. The rectangle is a four-sided plane with opposite sides equal and all angles are right angles. Triangle. The triangle is a three-sided plane with the sum of its interior angles equal to 180 degrees. Projection of a square plane. Front view. In this projections, the views are important. So concentrate on front view, top view, side view. What are front view? The front view shows true shape of a square with its sides and angles accurately represented. Top view. The top view displays the square as a line, showing its length and width but not its true shape. Side view also shows the square as a line, but this time representing its width and height. Projection of a rectangular plane. Front view. The front view shows the rectangular shape which its length and height accurately portrayed. Top view. The top view displays rectangle as a line representing as its length and width. Side view shows rectangle as a line representing its width and height. Projection of a triangular plane. In front view, it shows true shape of a triangle with its angle and sides accurately. Top view displays triangle as a line representing its base length. Side view shows triangle as a line representing its height. Now let's move on to the pentagonal plane. In front view, accurately portrays pentagon's true shape with its five sides and angle. In the top view, shows pentagon's outline as a complex shape, reflecting its five sides. Side view. The side view displays pentagon's projection as a complex shape, representing its height and width. Now let's move on to the hexagonal plane. Six sides. A hexagonal has a six sides with all angles equal to 120 degree. We all know that. 120 degree angles. Each angle is a regular hexagon measures 120 degrees. Projection types. The hexagon can be projected in two primary ways, using orthogonal projection or perspective projection. Now let's move on to the practical application and case study. Projection of a plane is essential in engineering drawing for creating accurate blueprints, 3D models, and product designs. This technique is used in various industries, including mechanical, aerospace, and architecture.
Let's move on to the further. We're going to solve two problems. First is square lamina, and second is we're going to solve a pentagonal lamina. A square lamina of 40 mm side rests on one of its sides on HP. The lamina makes 30 degree to HP, and the side on which it rests makes 45 degree to VP. Draw its projection. 40 mm is the side's height, and the lamina is 30 degree, side on which it rests. Make 45 degree to VP. Let's first draw the XY line. We have to select a point and angle should be 0 degree. Let's name this X and Y. Side of the XY line is VP and below the XY line is HP. We have to take a normal line, then select a point on the HP 40 mm side. Now length should be 40 mm and angle should be minus 90 degree. And it has been selected. Now the second angle should be 40 length and the angle should be 0 degree. Now the upper side is same 40 degree and 90 degree angle. Then we have to join these two sides. It has been the square 40 mm side rest on one of its corner on HP. Now let's take these projections. We have to dot this part. We have to take a line which is visible line. Then we have to join these parts. Now let's name these parts. Okay. Okay. Now let's name the above part of the HP. A dash is visible and D is not visible. D dash is not visible. In this part also, B dash is visible and C dash is not visible. Now this completes our first projection. Now let's move on to the second projection. For second projection, the lamina makes 30 degree to HP. We have to copy this part. Now let's go to the move. We have to select this copy. We have to rotate and we have to off this copy button. Then select the part. Then rotation angle is 30 degree. We have to select this. Take the angle between them. It is 30 degree. We have to project the lines downwards. We have to first select the normal line. Now we have done this part and we have to project the lines this part also. We have to show the projections. We will use sledge. We have to project line from downward also. Now let's visible this part by selecting a line, visible line. The second projection, we have to make the normal line to visible line. And we have done with this part. We will go to the third projection, which is rest makes 45 degree to VP. Let's select a line, normal line. We have to select a point. Angle is 45 degree. We have to name this part also of the second projection. This is there. And this is there. We have to copy this second projection, move. Then this is we have to on. Then we have to keep it on this. Then we have to rotate this part. Then we have done with this. For the projection, we have to take from A to A dash, then B to this B dash, then finally the D to D dash. We have to project the lines from B dash and C dash. Let's first name the part. A dash. This is B dash. C dash. And this part is B dash. Finally, we have to join this projection. Then lastly, we have to visible this parts which I have not visible firstly. We have to select the line, visible. line visible. And this third projection also we have to take visible lines. Now this complete our first problem. Now let's move on to the pentagonal lamina of 25 mm side is resting one of its corner on HP, while the side opposite to its corner touches to VP. If the lamina makes an angle of 60° with HP and 30° with VP, draw the projection of lamina. The first angle is for 25 mm, which is in corner, means we have to draw the pentagon on the left side. The sides are should be in left side and touches to VP. The second projection is 60° with HP and third projection is 30° with VP. Let's start this problem. First, we have to select line and normal line. The XY line should be normal line. We have to select a point. Angle should be 0° or 180°. We have to name the XY line. Upper part is VP and down part is HP. Point. We have to take a line. Normal line only first we have to take. Then we have to select a point. The size should be 25 mm. So length we will take 25 and the angle is 90° or minus 90°, sorry. Now it's completed. Then the second angle is also 25 length and angle should be 90 plus 72 and the third angle is same length is 25 and angle is 90 plus 72 into 2. Third also length is 25 and angle should be 90 plus 72 into 3. Then the last part we have to join this and this angles. We have completed the pentagon. We have to take these projections upwards. The projections should be in a normal line. Then we have to take a visible line. We have to dark these parts. Let's give the namings. This part is A, this is B, C, D, and this last part is E. Now, this part is A dash, dash, and down we can see B, which is E is not visible. So we will take in bracket E dash. Then this is C dash and bracket D dash. That's our naming of first projection. We have to copy this, then move. For move, this copy should be on. We have to select a point, then move. Then we should take rotate. We should rotate these angles to the 60 degree. Rotation angle should be 60 degree. Let's check the angles. We can see the angle which is 60 degree. We have to take the projection downwards. The projection should be normal line. A dash to we will take to A. Let's take the second projection which is B dash and E dash. Finally the C dash and D dash. This complete our projection. But we have to project from the first projection and to the second projection. From B to B dash. From C to C dash. From D to D dash. And the final one E to E dash. Now let's name this part also before projecting the parts. This is A. This one is D. Project the line. We have to take a visible line. Now A to B, B to C, C to D, D to E, and E to A. This completes the projection of the second. Now the third projection is 30 degree with VP. Now let's complete the third projection. Before going third projection, we have to select the diagonal parts. We have to select this, move. We have to rotate these parts by selecting rotate. Project the lines upwards. First, let's take the B dash. B dash. A dash to A dash. Then B dash and C dash. C dash and A dash to this part. This is E dash. Let's join the D to D dash. Let's give the naming. This part is A dash. This is B dash. C dash. D dash. E dash. Let's join these parts by taking visible line. A dash to B dash. B dash to C dash. C dash to D dash. D dash to E dash. This part. This completes the projections. Now we have to visible all these lines.
This completes our the three projections. Thank you for watching this video. If you have any doubt, comment on this video, and in the link in the comment section I will give comment section or description I will give my LinkedIn profile. Check out my LinkedIn profile also.